So good morning, everyone. Welcome to this month's training session. Today we're going to be talking about smoke control measures that are commonly found in new and existing buildings. Ali's going to go through that with us. Ali's a professional engineer with over 16 years experience working in the fire protection industry. Ali's expertise includes fire alarm system design for commercial, aviation, transportation, industrial facilities, and residential construction management and commissioning fire alarm systems. This code compliance review and condition assessments, as well as building and fire code consulting. So we've definitely got the right person for this. So you can just one thing for if you have anybody, how do you want to do question and answers, Ali? Do you want them as they come in, or do you want to have?
I'm okay with it. We have it at the very end that if people can ask, but if there is anything that they think they can't follow it, I mean, I don't mind if they interrupt me and ask the question. I'm fine with it.
Okay. So everyone, if you'd please put your questions in the question and answer section. I'll try and keep an eye on there and the chat, but if you keep the question and answers just in the question and answer section, makes them easier to find. Have had a couple questions, Ali. Is it possible to get a copy of your presentation afterwards that we could share?
Sure, I can send it to you. You can distribute to everyone.
Excellent, thank you. And I'm recording this. Is it okay if we share the video?
Oh yeah, sure.
Excellent. All right, thank you. So take it away, Ali. Thanks, everyone.
All right, thank you very much. Good morning, everyone, and thanks for joining this presentation. I'm really glad that I'm here to talk about this smoke control system. It's been a hot topic for the last few years, I believe. And I had that opportunity to work on this in a lot of projects in Toronto and in other municipalities. I don't like Vince did the introduction. I'm Ali Asraei. I'm an electrical engineer by degree, but I worked my entire career in fire protection, a lot of fire alarm system design, a sprinkler, smoke control system, building code, fire code, all that good stuff. And I'm working at Jensen Hughes, a fire protection company, basically. We have a lot of offices across Canada, US, Europe, Asia, Middle East, everywhere. So we do everything in fire protection engineering. And today we're going to be talking about smoke control systems, testing and maintenance procedures, all you know about it. So I'm going to go through the agenda very quickly. And again, for the question and answers, if there is anything and you think you should ask, you can interrupt me and ask by all means, that's fine. Or otherwise, we have a Q&A session at the very end of the presentation. So I anticipate this to take like about an hour, a little bit more than that maybe. Because I try to go through some more details. It's not like a I can't go through too much details because it's like getting very specific case by case thing, but I try to cover as much as I could in this presentation. So we're going to start with talking about a smoke control system and applicable code requirements for that. So where is it coming from and what is the smoke control system? What are the test and maintenance requirements for that? And talking about some measures that are in the building code and assessment of those measures. Initial tests that we do for the smoke control system to make sure they operate properly. And providing test and maintenance procedure. And then at the end, as I said, questions and answers. So let's talk about a smoke control system and applicable code first. This is something that smoke control system is not a defined term basically in Ontario Building Code and even the fire code. A definition has been included recently in CAN ULC 524 2019, which is not really an applicable thing to it, but since we don't have any definition, so I thought maybe it's a good thing to add it here. They call an engineering system that utilizes mechanical fans and dampers to produce airflows and pressure differences across the smoke barriers to limit and direct the smoke movement. So any system that does that is technically considered a smoke control system. And again, in lack of definition in OBC and OFC, we're using it from CAN ULC 524. And in the OBC, there are requirements for that, and it's for high buildings. There are two areas in the OBC covers the smoke control system. One is 326 in the Ontario Building Code that talks about high buildings. So high buildings, these are the types of the buildings that you see on the screen that consider high buildings. If you're group A, D, E, or F, major occupancy over 36-meter high, that's a high building. Or the same major occupancy or over 18-meter high, with cumulative occupant load factor exceeding 300. There's a bit of calculation involved there. If you're over 18-meter, it potentially could be a high building. Group B and C major occupancy over 18-meter automatically, or retirement home actually as well, over 18-meter, it's a high building. If you have group B, division 2 or 3 major occupancy above third floor, again, it's considered a high building. And if it is a high building, we are dealing with the requirements for the smoke control system are applicable based on articles 3262, 3263, and 3266 of the OVC. So what are the articles saying basically? 3262 of the OBC limits to smoke movement. A sprinkler building shall be designed in accordance with sentences 2 to 5.1 and MMAH supplementary standard SB4. It's called Measures for Fire Safety in High Buildings to limit danger to occupants and firefighters from exposure to smoke in a building fire. So basically, it says that, you know, we're just trying to limit the movement of the smoke to keep the occupants safe in certain areas that building code is asking for. And it provides the criteria so to limit the contaminated air into below grade and above grade stairs, for example, or some other shafts, depending on the measures that we're using. We're going to be talking about it later. And it requires some measures to be taken. And all those measures are coming from supplementary standard SB4. And the name of that is Measures for Fire Safety in High Buildings. This is like an example, like an image of a fan and then a stair shaft. So the fan is pressurizing the stairs. So technically, if there is a smoke cannot get into this stair from the floor area, right? So this area is pressurized, the smoke trying to get in, but the pressure air here, the pressurized air is not going to let the smoke to get into stair. And it keeps it safe for occupant to evacuate the building. That was 3262, and 3263 is talking about connected buildings. So if you have a high-rise building basically connected to adjacent building, either a high-rise or other buildings, building code is asking for measures again. This is typically known as measure N. So this is a measure from SB4. Again, there is a vestibule. Here, as you see, there's a connection between the two buildings. So this vestibule is either pressurized or naturally ventilated to outside. So it prevents actually smoke from traveling from one building to another. So that's another measure that we're taking. And there is an article 3266 of the OBC. It's venting to aid firefighting, means of venting each floor area to outdoors. It's either by windows, wall panels, a smoke shaft, or if the building is a sprinkler, you can use your mechanical system, basically those exhaust fans you see in the garages. That's for venting to aid firefighting. This is not necessarily part of a smoke control system unless it is in one of the measures that we're using. For example, when we get there, measure F uses this, and that becomes part of your smoke control system, but normally it's not considered part of the smoke control system. It's a good practice to include it, by the way. We can talk about it later on. So when you have all these measures, OBC is asking for a testing, and it's 32691. A system for control of smoke movement and mechanical venting required by 3262, 3266 shall be tested to ensure satisfactory operation in accordance with the procedures described in MMAA supplementary standard SB4. So there are some techniques and testing requirements in SB4 that need to be followed. And this is going to happen at the time of occupancy. Okay, this is a building code. We're not in the fire code yet. So building code is asking for an initial test. So this test result needs to be available at the time of occupancy. And once we have the satisfactory operation of the system, the building can be occupied. There is another area in the building code, subsection 328 of the OBC, talking about a smoke management. It is a smoke control system conforming to sentences 2 to 8 that shall be designed to control the movement of smoke within a building containing an interconnected floor space. So technically, we'll be having interconnected floor space. Then at that point, you need this smoke control system or management system, smoke management system. It's asking for specific smoke detectors at certain areas, dampers and supply fans here and there. There are additional requirements under 3284, 85, and 86. This is not necessarily a high building, and as soon as you have this interconnected floor space that does not meet one of the exceptions in the building code, you have to have this smoke control system. So as you can see in this image here, see the fire is going up. Basically, they're managing the smoke, right? So smoke is going through this atrium and out. So we try to prevent the smoke getting into the floor areas by adding air curtains here and here, like supply fans, pushing the smoke back into this atrium and providing this path for it to get out of the building. So that's another thing that we can consider as a smoke control system. The system maintenance needs to be provided for these type of systems by the designer of the system. We can talk about it later when we get to fire code requirements. And there is, again, an initial test requirement in the building code. 32811 says the systems for smoke control and venting described in articles 3284, 3285, 6, and 9 shall be tested to ensure satisfactory operation. Again, you see that this is building code asking for the test. We need that test before the occupancy if there is there's such a smoke control system in the building. Now let's talk about the test and maintenance requirements. Let's say we have that smoke control system in the building. It was tested hopefully properly and it worked and the building is occupied, and what are the requirements for test and maintenance? And where is it coming from? So obviously we're going to be talking about when the building is occupied, we're talking about fire code here. So Ontario has certain requirements for this. In section 7.3, it's inspection, testing, and maintenance of a smoke control system. Sentence 1 talks about a smoke control equipment that is asking for the maintenance. It shall be maintained in a manner that ensure that it is fully operational. Okay, pretty generic. Sentence 2 says where smoke control measures, so talked about those measures, so where those smoke control measures contained in commentary C of NRC. So we're going to talk about later. This is safe to say that this is basically SB4. So all these things that you see, these measures in that NRC user guide, so SB4 is written based on this. So basically, we can say if we have measures from SB4 that use the inspection and test shall be carried out as outlined in 7.3 of Division B of National Fire Code of Canada. When we go to 7.3 of National Fire Code, there are certain procedures and test and maintenance procedures for these systems. So basically, if you have a measure in your building, you got to follow National Fire Code requirements. The next sentence says, subject to sentences 2 to 5, which we're going to review, where the smoke control system is designed to meet the requirements of the building code. So the first one was smoke control measure, and this one is smoke control system is designed to meet the requirements of the building code. The inspections and tests for equipment shall be carried out in accordance with procedure established by the designer of the system. So there's a bit of an overlap here, as you see. This sentence is talking about a smoke control system, which could be a measure, but you can have a smoke control system, which is not a measure, basically a 328 system that we talked about. It's not specifically for high building. But then at that point, you need the designer. Even if there is a measure includes a smoke control system. Because to clarify a bit, when we're talking about measure, it's not only a smoke control system. Like let's say for a measure N vestibule or measure A, ask for certain vestibules with fire resistant rating to separate, below grade shafts from the floor area and stuff like that. So those are not technically smoke control system. It is part of the measure, but it's not the smoke control system, right? So There's an overlap. So a measure includes the smoke control system most of the time. We can say probably all the time, all of them having like some fans and sort of things like that, that is considered a smoke control system. But if you have a smoke control system, it's not necessarily a measure. Could be a building that you added a smoke control system as part of an alternative solution or whatever other reasons, that is not necessarily a measure. So either way, you need to establish a test and maintenance procedure for it. So where procedure, the sentence 2, we're getting there, that why we're doing this thing. Where procedure described in sentence 1 are not available, smoke control systems shall be assessed to ensure satisfactory operation using techniques described in supplementary standard SB4. So basically it says designer needs to provide that. Well, what if the designer didn't provide it? So we have a lot of existing buildings that don't have that procedure. And if it's not there, the system needs to be assessed and a procedure needs to be established for the system. And the other sentence, sentence 3, says upon completion of the assessment described in sentence 2, written procedure for periodic inspection and test shall be established. Okay. And sentence 4 says that this basically the procedure described in sentence 3 shall bear the signature and seal of a professional engineer or an architect. So what it says that if you don't have the original basically test and maintenance procedure provided by the designer of the system, you need to involve another engineer to do an assessment of the system and put together a procedure, stamp it, and give it to you. So moving forward, the owner can follow that procedure to maintain the system. And the last sentence says that obviously the inspection and test established under sentence 3 shall be implemented. So as I said, it is safe to say that NRC is basically that SB4 that we have. So we have to assess the smoke control system based on some techniques that are provided in SB4 and put together a maintenance procedure, and moving forward, do that maintenance based on the procedure that is established for the system. So talking about smoke control measures and assessments. So what are these measures that we're talking about in the buildings? Supplementary standard SB4 has following measures. So you see on the screen is from A to measure N. Those are that are bold, they're pretty common ones. So measure A is applicable to fully sprinkled buildings. A lot of new buildings that you see these days, a lot of residential buildings, since they're fully sprinkler, they're required to be fully sprinkler now. And this measure applies to them. And measure F is another one when you see for a lot of older existing buildings that the building at the time was not a sprinkler, or is not a sprinkler even now, and it's a lot of residential occupancies. You see pressurized above grade stairs, elevator shaft, and all that. So that's measure F. Measure G has a lot of similarities to measure F. So between the two, most likely you're gonna deal with one of them when you're dealing with a lot of existing buildings. Measure M is another, I can say it's pretty common. When you see a lot of balconies for a lot of residential suites, and that could be a measure M building, because when you have that, it waives a lot of requirements, and technically you have that on a pressurized below grade, and that's it. And measure N is very common, even in the new buildings when we're connecting the high-rise buildings. We try to separate buildings from one another. So the concept of this measure N is being used to separate the buildings and call them different buildings. So measure N is pretty common. It's a pressurized or naturally ventilated vestibule. So these are basically, it could be a lot of other, like, these other measures could be used in the buildings, and these are just the common ones that I'm talking about. Yeah, I've dealt with buildings with other measures too. You're just gonna have to figure out what measure was used for the building, and we're gonna get there. So the typical measures that I said are applicable to the buildings, measure A is very common for the new buildings. The design criteria is per supplementary standard SB4. It's asking for below grade stairs to be pressurized. So you have a pressurization equipment for the below grade, and there's a vent to outdoor at or near the top of the stair. So you put the fan at the bottom of the stair and the kind of a louver and exhaust or whatever at the top of the stair. For above graded stairs, it's only natural ventilation which is required. So technically the door at the bottom of the stair, if you can open it, and as long as it can stay open, and it can be manually, you see in a lot of buildings, they have the automatic door opener with the fire alarm. It's not a requirement because the code is asking it's openable and can remain in this position during a fire emergency. So if they have like a magnet, sometimes I've seen people putting on a wall so you can push the door open and it stays in open position, or some sort of chain I've seen sometimes. And a lot of occasions you see automatic door openers that open at the bottom of the stair. And no fan is in it necessarily. It's just a natural ventilation, which is acceptable since the building is a sprinkler. I don't know how practical it is, but it is the building code. So, because sometimes in the winter, if you do the test, there's a lot of pushback of the air going to the stair instead of the air going out. But it is permitted in the code based on measure A. So when you have that, there are control switches in CACF room that we need to have, another requirement based on this measure. So you can stop the air handling system if applicable, if you have air handling system serving more than 2 stories, let's say, generally. So you have to have a switch for it, which is pretty common. Again, you see that switch. And you should be able to turn on the fans for pressurized stairs. So if your below grade is pressurized, which is required to be pressurized based on this, so you need switches in the CACF room for that. So that's a measure A, pretty typical. In terms of the smoke control, so just to clarify again, we're not talking about construction requirements as per measure A that is asking for vestibules if your elevator shaft is penetrating above grade, below grade, and all that things. It's not part of this. We're just focusing on the smoke control system as part of this measure, right? The other typical measure that is applicable to the buildings, a lot of existing buildings again, is measure F. Design criteria, it has some other additional basically criteria because the building is not as fully sprinkler. Usually when you see measure F, you can see a sprinkler in the basement parking area and that's it. So in the or garbage chute and stuff like that. But then the actual floor areas, they're not a sprinkler. So it is asking for above grade stair pressurization. When you're pressurizing the stair from above grade, you need to have the ventilation, the vent at the bottom of it, which is typically the door that opens. If you need more than a door, so you need to have certain stories that you end up with a certain size of the opening that you need. The door is not enough. A typical door is typically 1.8 square meter opening. So if that's not sufficient, you got to add louvers on top of it and dampers and all that. But typically, 1.8 square meters is what you see unless the building is very tall. Below grade, same requirement. You add a fan and same requirement as measure A, and a vent at the top of it. So when you're pressurizing from the bottom, you vent it at the top, and pressurizing at the top, you vent it at the bottom. So you maintain that flow within the shaft. And the other requirement is for elevator shaft. So if you have a firefighter's elevator shaft, you need to pressurize that. So basically a fan pressurizing the shaft to keep it clean and clear of smoke. If you have other elevator shafts other than firefighter's elevator shaft, when the elevator serves both above and below grade levels, term is below the lowest exit level. Lowest exit level typically is your ground floor. And if you're serving below the ground floor, basically that elevator serves below the ground floor, you need to pressurize that. The other thing is ventilation for below grade. So where firefighters elevator serves both above and below grade levels, again, below the lowest exit level, we have to provide vent to outdoor or mechanically exhaust the below grade floor areas. So this is where I was talking about, we talked about the venting to aid firefighting. So mechanical system is not part of measure A to be considered as part of your smoke control system. But here specifically measure F is asking for that mechanical exhaust system for below grade floor ventilation. So if you have this scenario and you have this elevator that serves both above grade and below grade, you need to have this vent to outdoor, which is typically not provided because the parking is entirely, most of the time, underground. So they use the mechanical exhaust system to vent that floor area. So that becomes part of your smoke control system here, right? So, and then test and maintenance procedure is applicable to it. So this is basically measure F. Other requirements, if you have other shafts, other vertical services spaces, you may have to pressurize that. Air handling unit shutdown. If there's more than 2 stories, again, you need to shut it down. And it comes to the last requirement, that switches that you need in your CACF room. So you need to control all those fans, air handling system. If there is a damper provided, you need to have a control for that damper. And opening and closure of any, if there is a vent in a vertical services space that provided, you have to have a switch for it. So mechanically you can open and close them. So basically, when we deal with the smoke control system test and maintenance procedure, there are 2 scenarios that we are dealing with, and we have 2 different approaches. What is applicable to new buildings? Basically going for occupancy and maintenance, and maintenance procedure is not provided by the designer. In a lot of cases, designers either don't know how to do it or not aware of the requirement. So building is going for occupancy and they don't have the test and maintenance procedure for the system. Technically, it's not a requirement, but as soon as the building is occupied, this is applicable to it, right? This becomes a fire code requirement. It's similar to, let's say, a fire safety plan. You know, you guys ask for it at the time of occupancy. It's not technically required. Building is not occupied, but you know soon it's going to be occupied, so you need to have a plan in place. So same thing. In this case, for us, if we're involved as an engineer to do this assessment, it's easier access to all the design documents here. It's a new building, you have all the mechanical, electrical, architectural, everything that you want is there. And designer may still be involved in the project most of the time because there's still, you know, the building has not been occupied or it's been occupied recently. So we have access to the designer to ask questions when we're doing the assessment. The other one is existing buildings, where the test and maintenance procedure is not available. 99.9% of the existing buildings. Honestly, I haven't seen anyone. I just put that 0.1% for, I don't know, maybe some buildings haven't, but I haven't seen that. So none of the existing buildings have that procedure, and nobody's following any maintenance procedure for these systems in existing buildings. And the challenge here is that the design documents may not be available. You know, we're dealing with a 30-year-old building. Who knows where the mechanical design document is? So it's really hard to assess these buildings. And understanding the design and design approach that was taken before, like 30 years ago, and measures taken, it's not impossible. We get it done, but it's a little bit time consuming. And compare with a new building, obviously, it's much more work. So typical steps for the new buildings, let's talk about. For the typical steps that we take for new buildings, we review the mechanical drawings. So this is the part of the assessment. Let's say we're involved to do an assessment, and this is how things are going to happen. So we review the mechanical drawings to understand the measure applied to the building. Look at the location of the equipment. Again, for the new buildings, if it's a sprinkler, it's pretty easy to understand. It's measure A, but I've seen some weird things too. I mean, it's a measure A, but you see stuff here and there added. It could be part of an alternative solution. A lot of other things you don't know happens in the project, but you got to carefully review the mechanical drawings to understand the measures applied to the building. Reviewing fan schedule to get an understanding of the size of the fans, the location of them again. This is to confirm that the system was designed properly. Okay, so you're an engineer involved here, you're an engineer involved there, saying, we're reviewing the mechanical, and the designer designed the 10,000 CFM fan for this, let's say. And you go to the building code, you review the requirements of the measure that was applied to the building, and based on the number of the stories and whatnot, you double check with the fan side, you see, okay, the designer is right. They designed the system properly and matches. And the other thing, it doesn't mean that when the system was designed properly, it doesn't mean that it was installed properly on site as well. So the other thing you need to do is review the shop drawings. So this is to confirm that the fan that was provided by the contractor matches the design. Sometimes the designer asks for a 10,000, somebody put in shop drawing an 8,000 CFM fan. They're like, okay, whatever, this is going to work. We don't have a 10,000 CFM available. Let's put 8,000. Or even more. Sometimes more is not better. We're going to talk about it. Like, there's a 10,000 CFM fan designer design. Let's put like a 15,000. Who cares? It's more pressure, better. No, you're over pressurizing this there. The doors cannot be opened properly. So kind of stuff that we're going to be dealing with. We can talk about it later. But yeah, the next step would be looking at the shop drawings to make sure that the system that was installed is as per design. That's another thing. So the second step, thumbs up. Okay, the system was installed properly. The other thing is that, okay, the system was installed, but is it performing properly? Is it this is a 10,000 CFM design, 10,000 CFM fan was installed. Is it performing as a 10,000 CFM or it's deficient? You don't know. Even if it's a new product, sometimes they're deficient. So this is where you need to ask for the test results. Usually they call it air balancing in the project. Like a lot of HVAC contractors call it air balancing results. And as part of that, you can confirm some of the information that you're looking for. So we're looking for the information and see, okay, this matches. Yeah, they tested the fan and the performance shows it's 9,900 something CFM. It's pretty close to 10,000. We don't expect it to be exactly 10,000, right? So it matches and it works. So basically the system was designed. And if you see that result and you confirm that result, no need to conduct a test again. We're talking about a new building recently being tested or recently occupied. We don't have to duplicate things, right? We don't have to add additional, headache or cost to the project. You can confirm it based on the test result. That's fine. Because the test result was done recently, right? It's not like after 15 years we're in the project. It's a new building we're talking about. And as part of it, we review any alternative solution applications that were provided for the building and, just to make sure that we're not missing anything, because sometimes some alternative solutions involve a smoke control system, pressurizing certain areas, venting certain areas. So just to make sure we have everything. And when we have all that, we provide a test and maintenance procedure. Moving forward, they can use that procedure to test the system and maintain it properly. Periodically, it's every month, every 3 months, annually, every 2 years. So it depends on what system you're dealing with. And we give them that procedure and they follow it after that. So that's basically an assessment that we're doing. There are additional steps in here, as I talked about. We may need to contact the designer to clarify some design information, or maybe the contractor to clarify some test results. And, if you're not happy with the test results or not convinced basically something was done properly, we have to then at that point, we make a decision to do a test ourselves to just make sure we get the numbers and the numbers are right and whatnot. So sometimes at the first step, you see the designer is not right. So you got to go back to the designer and bring it up to their attention, which is not fun. The building is constructed, occupied and all that. So it's, I don't know, it's pretty hard. But anyway, this is, if you're involved as an engineer, this is our job to do it. And yeah, so we may have to do a additional test to make sure that everything is done properly. Once the assessment is concluded, the satisfactory operation of the system, maintenance requirements to be established. At this point, we can give them a maintenance procedure, and going forward, they can follow that and they should be good. We get to existing buildings. these are the typical steps that we take for existing buildings. Okay, so we're talking about existing buildings. I mean, existing in place for years, 10 years, 20 years, 15 years, 30 years we've dealt with. So the steps are pretty much the same, but slightly different. So it's time consuming a bit, as I said. We have to review the mechanical drawings, as I said, to make sure that to just understand the system, let's say. And usually they're not available on site. And we're going to ask for the cities. If you go to different municipalities, they have a good record usually, and they can give it to you. It rarely happens that there is absolutely no information about the system. But we were so far able to get all the drawings that we were looking for, even though they were pretty old, but it is something for us. It is really helpful to get an understanding of the system. So we'll review that to understand the measure that was applied to the building at the time. If you're lucky, there's a fan schedule there. You can review the fan schedule. The same steps, we have to go back, and the only challenging thing is here that we have to understand what the code of record was at the time, because we can't compare the design of 30 years ago with the new code requirement and say this is all wrong, you have to redo things. Like, no, the system was installed back then. We have to see what the requirement was back then and kind of compare it with that requirement and see, okay, back then they asked for 5,000 CFM fan, or they didn't even ask for a fan here at this area. So they're good. And based on that, as I said, there are some relaxations usually to waive some requirements, especially for, a lot of apartment buildings, believe it or not. Like, there are some areas that they say, you don't have to pressurize your stairs in an apartment building. And at this point, we have to do a site visit, even though we have a test result. Sometimes, like, 15 years old, buildings say, oh, we have the original air balancing result. That doesn't mean anything. That system was not being maintained for 15 years. So if they tested 15 years ago and it worked, it doesn't mean that if we do the test today, it's going to pass, right? The system wasn't being maintained properly, right? So basically, we have to do that test. We call it initial test. And just to make sure that the system performs properly and satisfactory operation. Again, there are techniques in SB4 we use to make sure that the fan or the whole smoke control system works properly. If there are deficiencies here, they need to be rectified at this stage before we can give them a procedure for maintenance, right? The first step is just to make sure, and the fire code says satisfactory operation. If you're not satisfied with the operation of the system, then we can't give them. They have to first fix this, and then we can maintain the system after that. Okay. I don't know, Chris, you have something here? I didn't see any question yet, Chris.
Yeah, sorry, Ali. There's a couple that we've answered in the Q&A on the bottom of the screen. And then there's a couple that we'll just save for you at the end regarding air balancing and below grade stairs.
Oh, okay.
Are you not able to see those in the bottom of the screen under Q&A?
I think I just clicked something and it opened up something. Yeah.
I mean, we can read them out at the end too, if you like.
Okay, sure. Yeah. All right, so let's continue with initial tests. So let's say we're going to have to do a test in a building. Again, we call it an initial test. So this test is to confirm the satisfactory operation of the system. That may include measuring the fan capacity. We may have to do that. Measuring differential pressure between pressurized area and adjacent floor area. Let's say they measure N vestibule, they say it's pressurized. We have to make sure that there's enough differential pressure between this vestibule and the adjacent floor area. So, or it's just like a little fan just blowing some air. It's not sufficient. Sometimes measuring and confirming the size of the supply and vents, and operation of the doors and dampers, anything discharging to outside, like a door discharge to outside, or is it damper? Is it opening properly and whatnot? Manual activation from the CACF room and automatic activation by like a fire alarm system for the fans. We have to confirm that. And operation of the doors leading to pressurized stairs or vestibule. We're going to talk about it like a door force reading that is required. We have to do that. It's a 90 Newton permitted as a maximum in the OBC. But we got to talk about it in SB4. There is kind of a permission. It basically tells you you can't design a pressurized area with a door force reading less than 130. That would be challenging. So 130 Newton is sometimes we consider that because I know it is something interesting because building code is asking for 90, but when you go to SB4, it says it's basically impossible to do a design like that with the measures that are in the OBC and the SB4 to design a pressurized area with a door force reading of less than 130 Newton. Well, that's a big challenge. We're going to talk about it at the end. So there are tools that we're using for this type of test, initial test. This is one of them, an anemometer. It's measuring the air velocity. Basically, you can, sometimes there is a hatch in the dock, so you can open it and put this inside, and when the air flows, it's just this thing keeps turning and basically gives you a number that you can understand the velocity, the air velocity. Or if it's not available, you can do it at the very end here or here, even at the intake or here. So it depends what is available. A proper way is a hatch available. You open it and put this inside the dock, right? But it's not all the time something that you can do because sometimes there's a shaft around it, built around it, and there's no access technically to it. Another tool we're using, it's manometer. It's measuring pressure differential. So as you can see, there are two spots here and here. These are the tubes. You add the tubes here. One of the tubes goes to the pressurized area and the other tube stays in the floor area. And it gives you a number here that you can read. And that gives you the differential pressure between the pressurized area and the adjacent floor area. So there are in the SB4, there are some numbers that we need to follow. Let's say for a measure N vestibule, they're asking for 12 Pascal pressure differential. So it means when your measure N vestibule is pressurized, the pressure in that area needs to be more like by 12 Pascal than the adjacent floor area, just to make sure the smoke cannot get into that vestibule. Which again is one of those things that you don't see very often because usually these measure N vestibules have just a little fan there. And I don't know if the 12 Pascal was never measured there or whatever the reason. So I don't know, because there are no, basically for measure N, if you go to SB4, there are no certain design criteria other than the performance. So basically it says the performance should be 12 Pascal pressure differential. So based on the performance, you got to reverse it and design the system. For the other fans, let's say measure F and measure A, they say based on number of stories, do this and this and this. But when it comes to measure N vestibule, they're looking for 12 Pascal pressure differential, which you got to do whatever you want based on the size of the vestibule. The designer, I mean, has to do that to get that result. So the result is important for the SB4 to be 12 Pascal. So whatever size of the fan you put there, it's up to the designer to make that decision. I can see that why they didn't provide the specific requirement, because it's challenging with the location of that vestibule. Is it close in a parking that, you know, close to the entrance door of the parking, which the air pressure is a lot over there, or the size of that vestibule. So these are all a lot of different factors that can affect this. So it's up to the designer based on the location of this vestibule to get that performance, basically. The other thing that you can use is a tracer smoke. This is in National Fire Code. It's permitted if you want to see the pressure from a pressurized area is coming to the floor area. So you can use this, and the smoke is gonna, you can see the smoke moving towards your floor area. So basically, if you have a pressurized stair and keep this device close to the stair, the smoke should travel towards your floor area, so it cannot get into the stair. This is a way when we get to the test and maintenance procedure, you'll see that's one of the ways permitted by National Fire Code. Another device is a door force gauge. This is obviously to measure the door force opening. We talked about it in exit doors or any pressurized area, pressurized vestibule. We need to make sure that the doors can be opened by the occupants. Excuse me. So yeah, we use that device. I talked about that 130 Newton in SB4 and 90 Newton in OVC. So there are these different things that it comes down to your judgment. So we're going to talk about it at the end, the engineer's judgment that, you know, which number they're going to accept. And what are the challenges? So one of the challenges that we have with the smoke control systems is mostly for existing buildings that are not sprinklered. So the story is that, like, let's say there's a fan here. You see, this is a typical design on the right, like B, top injection. So the fan is at the top of the stair, and you basically, the size of this fan depends on this number of floors it's serving. So if you get to the certain height, more than 20, 25, 30, so when you go over 20, typically, this fan becomes like a massive fan. So when you put a massive fan at the top of a stair and inject the air through this shaft for the first half, or the first, like the quarter, like the quarter or the half or 1/3 of it, mostly, the 1/3 is pretty fair to say, is becoming overpressurized, and it's expected, right? So you're putting a massive fan at the top and you're injecting air all the way down. So by the time the air gets to the bottom half, basically, the doors can be opened properly, so the pressure is not that significant. But for the top floors, it's a challenge. And I've been in projects that I couldn't open the door. Like literally, you can't just push it, and you know, I'm relatively young. So you can talk about, like, and think about other occupants in the building, they want to exit, and at that point you're thinking, what's the point of this fan here, right? The exit is an exit. You want the exit first. First thing is you want occupant to exit the building. You're basically, it's like you're locking your exit doors by just overpressurizing it, right? So this is a significant issue. So we've been in the buildings, we worked with fire department, and we had to decommission temporarily the fan because we wanted the exit to be an exit first, and then you know, think about pressurizing it. So the solution to that, and obviously at the time, even right now, Measure F is not talking about, but right now the good thing is nobody uses Measure F because the buildings are all sprinklered, so you don't need the fan at the top. So your above grade stairs are not required to be pressurized. But for the existing ones, the solution is you have to do a duct work, and we call it multi-injection system. So instead of dumping all the air at one spot into the entire shaft, so you basically put a little bit air here, a little bit here, here, here. So it keeps the stair pressurized the way the building code wants, and it's not over pressurizing because it's not dumping all the air at one spot. So it's a multi-injection point. But this is very costly, to be honest with you, and a lot of work need to be done to do this. But I think it is what it is. If it was not, if it's designed at the beginning, yeah, that's easy, right? So you can just do that at a little bit more cost to the project, but it's way better than this solution. So anybody who goes for a new design, if they have to pressurize an above grade, it's highly recommended to go this way with multi-injection system, not just one point injection. All right, so let's say we did the assessment and we did the initial test. Now everything is good. So assessment confirmed that the system was designed properly, everything is okay, and we did the initial test, the system was performing properly, or if it were deficiencies, they've been fixed and all that, so everything is good. Now we can put together a test and maintenance procedure. Again, going back to OFC, sending you to National Fire Code, which was asking about basically inspection and test procedure for a smoke control system. If you go to 7.3 of National Fire Code, there are certain requirements there. Some of them are common for all measures. It says where vestibules or stair shafts are pressurized, doors in the path of exit travel to be tested to ensure they are operational when the entire smoke control system is being tested. So this is one thing, one of the tests that we do, we put the entire system, not only one shaft or, you know, one vestibule here and there, it has to be the entire system because they affect each other. So when you have them all running, it's different than when you have one of them running, even though it's that, like, let's say I'm testing the doors for this pressurized stair. If I turn that on only, I may get different numbers when I turn on the entire system, right? So we have to make sure that the entire system is working and then do the measurement. And there were other tests at the 3 months intervals. CACF room switches need to be tested. Anything that you have to manually operate it to make sure that from CACF room you can initiate the fans here or there and turn them on or off. And of course, automatically from the fire alarm system as well. Closures in openings to outdoors or doors, if you have doors or dampers in vertical services spaces that are required to be vented, we need to test it every 3 months. These are based on, again, National Fire Code. Closures in vent opening to outdoors and above graded stairs, they open manually and they remain open. Okay, so again, measure A, requirements for above graded stairs, you don't have to have an automatic door opener, right? So as long as manually it's openable and it can remain open, that's important that it can remain open, right? Because it's manually openable, but how do you want to keep it open? Should be something there to help with that. And for below grade, the same thing, they open automatically and they can remain open. These are actually the requirements for measure A maintenance requirements, right? So when you go to National Fire Code, based on different measures, there's some commons that we talked about, that common one that you have to measure all the doors, but for specific measures, there are requirements. So this one is for measure A, that you do this because the above grade is naturally ventilated. So you do that. For above grade is pressurized. You just make sure they open automatically and they remain open. I mean, the vent side of it. And it comes to measure F, they're slightly different because there are different areas that are pressurized. So elevator shaft, below grade floor areas and all that. So there are vents and the switches from CACF room. So you have to confirm all that. I mean, one thing to note here that, like, if nobody provided that switch from the CACF room, we usually recommend that because it was approved at the time with the design that way, right? So there are certain things that we usually recommend, and most people take it and do it. But other than that, I don't think we can do anything because this is an existing building. Unless there is like an issue with the design and performance of the system that we have to raise it. Again, from the CACF room, we make sure dampers and doors can be open and closed, and we can initiate air supply for elevator shaft and pressurized stairs. Closures to outdoors, these are common. We have to make sure closures and vent opening to outdoors. Again, for above graded stairs, these are the doors at the bottom. And closure and vent opening to the outdoors and below graded stair. For below graded stair, could be the door to outside, but that vent is basically more than what building code is asking. It's okay as long as it's not affecting the performance of the system. Sometimes a big vent, bigger than what is required, it's affecting the system. It means that system is less, basically the area is less pressurized. let's say. So these are the things to be considered. So as long as, but the designer hopefully considered at the time of design. And there was a test for measure F, asking for like it's every 2 year. The National Fire Code is asking for pressurized stair and elevator shafts to be tested in different seasons to ensure movement of air is from pressurized area to floor area. So basically, every 2 year, you can do it in the summer and in the winter season. Just make sure in both seasons, because of the stack effect and temperature outside is affecting a lot of these systems in the building, which again should have been considered at the time of the design, because there is a sentence in the OBC and there's an SB for, there's a supplementary standard for the temperatures and whatnot they have to follow. So, but we have to make sure that this works in both seasons. If you want to, we did that, you know, if you want to skip it season, you have to provide it with calculation. So if you can provide a good stack effect calculation, say, okay, I did this in the summer, this is the test result, but I am 100% sure it works in the winter too, because the stack effect that I'm getting in the winter is this and this and this. And now I can confirm that this system is going to work in the winter properly as well. If you want to do that calculation, or just, you know, do it in the next season. So every 2 years, the next, like the couple of years, do it in the winter and just make sure the system works. There are additional tests that we typically include, like manufacturer required or recommended. So sometimes, you know, the lubrication of motors, like belt inspection, these are typical inspections that you gotta have to do as part of it, right? And you know, venting to air firefighting is something that some people may argue that, oh, it's not part of my smoke control system, why do I do it? Like, why don't you do it? Like, it's we're doing 7.3, but this is addressed in 7.2. 7.2 of the fire code is saying, you know, an event for firefighting to be tested. So when you're doing a 7.3, I think it makes sense to include it in the same document and just do it, because I bet you nobody does that either. So, and if we do elevator, if the elevators are pressurized, so the other test requirements under 7.2 that are for elevators, we add them too. Because again, you're bringing in an elevator technician on site to do this test, so might as well do the other test and kind of document it somewhere in one document. Right? So if it's not in pressurized elevator, yeah, that's fine, like a measure A. I understand that. But again, like something like air handling system, your exhaust system in the parking, to me, it should be included. Excuse me. I typically don't drink this much water. I don't know what's going on. But
Lots of talking makes you thirsty.
I know, I think I haven't talked this much for a while. So retention of records, there's another requirement in the fire code for this, and both assessment, when you're doing an assessment, and periodic maintenance, it should be final report that basically with the assessment, test result of your initial test, if you did that initial test, and kind of an empty form for the owner to use it moving forward for the test and maintenance procedure, should be attached into that report. It needs to be submitted to AHA for review and approval, and you got to record it and do the periodic test. It needs to be provided to the AHA upon request. So typical as other records that you need to keep for the fire life safety systems. And finally, I think we're at this question. I can drink a little bit more water and answer some questions. Okay, so
Ali, are you able to see the Q&A questions now?
yes.
So there's 4 of them there right now. I don't know if you want to start from the top. We've answered a few. But if you see
Okay.
the open tab on the left side, there's 4 of them right now.
Oh, the answer, that means those are like the others. Okay, the open
Yeah, if you
ones
click
are
on
the one.
answered, you'll
Okay.
see those are 3 that we've given responses to. Yeah.
Consider residential high rise with an underground parking garage. Okay. Under measure A are below grade stairwells serving only the garage and are away from the building required to be pressurized. If the stairs are discharging directly outside, or if they only serve one level, there is a sentence in SB4 that gives you kind of a permission to not have that pressurization. And do you see my screen right now when I'm sharing the SB4?
Yes.
If I can find that sentence, I think here. So see here, the highlighted one. These provisions are intended to apply to common building designs where a stair serving floors below the lowest exit level is open to the exterior. So those are the openings. It's not the one that you're talking about. Or the stair serves only one story below grade. So if it's only one story, compliance with the following provision may not be necessary. So technically for one stories, I've seen that, and there's no really, because what do you want to do? Like, you pressurize it right away, gonna there's like a one landing above, you gotta basically vent it out, right? So yeah,
Yeah.
technically that gives you
So it's not about the direct exiting to the exterior. It's more about if it's serving
number of
1
stories.
story or
Yeah,
less, right? Yeah. Okay.
yeah. Next question. I hope I answered it. I don't know. If there's anything else, let me know. The initial test they conduct for the smoke control before occupancy, is this test referred as air balancing, or is the air balancing test only a component of the initial test? So building code is asking, they call it for the test, so those sentences are asking for the test results. Basically, they do it as part of the HVAC system. So what happens is that the HVAC contractors go to site and do it as part of their HVAC test, and they call it a air balancing, right? The air balancing report includes a bunch of other information that is not relevant and related to the smoke control system, but the smoke control system is basically treated from their perspective as a fan, and they do it as part of that air balancing. So it doesn't matter as long as it shows the satisfactory operation. The only part here that is missing for me, that who reviews this, right? So is it the HVAC inspector reviews it, or the fire inspector reviews it for the municipalities that they have fire inspector, or part 3 inspector, let's say. I think it's mostly probably is being reviewed by HVAC, and I don't know how much they're aware of this and all these other requirements that here afterwards we're going to be dealing with. So it seems to me that part is kind of missing in between, but the result is there as part of the air balancing report. These questions are in order, right?
Yep. You have 2 questions on there's 2 comments about 9.6. You're on the next one, right? On 9.6.2.16.
9.6.2.16.
Is this the longer question here?
Oh, okay. I've come
And there's a
across the
reference.
existing 326 building.
Yes,
Built
and there's
prior to 9,
there's another comment on this further down as well on what about 9.2 or sorry 9.6.2.16 sentence 2.
Which only have pressurized elevator shaft and air handling shut down for smoke control. However, each suite has access to exterior balcony. Should the requirement be enforced in this scenario? Engineer procedure for periodic testing. If the building is a high-rise building, you need that. If an engineer doing it, like based on what you're providing here, it seems it's a measure M to me. If they have balcony and they have no fans and whatnot, but they need a pressurization for below grade, unless they, sometimes measure M says, let's say below grade pressurization and balconies, But the below grade pressurization, they applied at the time for an exception for apartment building to waive that requirement, or if it was just one story, same as the one we talked about. So the waive that, so you don't see that in the building. And that's why probably it still is, to me, you need that to be assessed by an engineer to understand what measure was applied to the building. And they have pressurized elevator shaft. So to me, they need to maintain that, right? So that fan is important too. And also air handling shutdown. So you would be surprised, so nobody touches those stuff.
If I can add to that one too,
Yeah.
it doesn't matter if the requirement's coming from retrofit in 9.6 or if it's coming from the building code, right? 9.6 is kicking you back to the building code anyways.
Yeah.
So you have the same, and they're both referencing smoke control measures, right? So if you have measures in an older retrofit era building that predated the building code, it's maintained the same way if you have a measure, right? So it really shouldn't make a difference.
Mm-hmm. Yeah, exactly. So yeah, I didn't read the equivalent as per OFC. Yeah, 962. Yeah, it doesn't matter, as you said, Chris, that where it's coming from. So still you need an engineer to do this assessment, right? So to look at all these stuff provided for the building, see, okay, this is what measure they followed, what's going on in this building, put together a report, and based on that gives you a maintenance procedure.
Yeah, and Ali, you're aware of this. We chatted about this last week, but we've discussed this with the OFM too, that when you're looking at 7312 for testing requirements for a smoke control measure, whether it was installed in the 70s or 80s or 90s or 10 years ago, it doesn't matter. There's no cutoff date or anything like that. So
no,
7312 would apply to any measure, regardless of when it was installed.
Yeah. Any measure, and the next sentence is talking about anything that is in the OVC, basically, like anything with the Ontario Building Code, you gotta have to do it. So at some point, if either they follow the measure or they just came up with something which is not a measure, but it's still based on the requirement of the OVC, that is your smoke control system, and 7.3 is applicable to it. So the next question, who would you, the questions disappear, right?
Yeah, I think one of the other panelists is probably just missing them once we've answered them.
Yeah, so that was, I was confused, like, I was at the third one and what's going on? So who would you recommend to do the smoke control test? Which trade? I don't know if we can do that or recommend anything. Anybody
Yeah,
here?
do you want me to address that?
Yeah.
So you're commonly going to have consultants like Ali involved. You're going to have HVAC companies involved. But the fire code is silent on qualifications for smoke control testing. So
for the maintenance, yes. For the assessment, and engineer, right? So
yeah,
you need an engineer to do that, and to assess the system. As part of that assessment, they need to make sure that the system is operating basically satisfactory based on the requirements of SB4. So that needs to be done by an engineer. Moving forward after that, who does that? I think that's where Chris is saying this is silent about it. But yeah, it's an engineer you need to do the assessment, and gives you a stamp report with the procedure moving forward. After that, your maintenance staff, usually what I've seen in the buildings, they give it to HVAC contractor because it's technically what they do. Or some companies, they came back to us, owners came back to us to say, can you guys do it? Sometimes we accept doing that, like moving forward. It's like, annually, they're looking for annual and, every 2-year inspection kind of things. So we can do it too. Yeah, Tyler says professional engineer or architect. Yeah, I've never seen an architect touching it, but yeah, because every time that there's a professional engineer or architect, they're hand to hand that being referenced in the codes. So how does the testing you explained translate into the bottom line requirements of OBC Division B32622 for 1% of smoke contaminated in 2 hours? I think that's the, so if you follow the measures, those measures automatically take that into consideration. That's something that is provided by the OBC, and you can, when you follow that, when you go through the SB4 requirements, it's explained there. And those requirements that they're asking you for the fan size and the vent size, So they all consider that of 1% of smoke contamination into consideration when they put together those measures. So technically, nobody goes to just nobody provides a design saying that I did the calculation. This is a 1% of smoke contamination in 2 hours. As long as you follow a measure, that's basically acceptable because those measures are supposed to basically be based on this requirement. You know, unless you're doing something different, a part of an alternative solution, you do a modeling, right? So we've done that in the past. That you know, you do the modeling and you make sure that there's not much smoke there, or not more than 1% within 2 hours. If you're not following a measure, technically you're creating something new which has not been proven to be working. So then you have to prove it somehow. It was technically a modeling.
You know, the next one's going to be challenging for you to answer, I know.
If an existing building has no previous test records, would you insist that an engineer be involved prior to anyone, contractor, fire department official, fire alarm technician? All these questions are moving. Testing the smoke control system. There's no previous test records. Would you insist an engineer be involved prior to anyone? Testing the smoke control systems.
I don't know.
Technically, that's what the fire code says, right?
Well, it depends on if it's a measure or a system. And sorry, I don't know if everybody can hear the question because I don't know if everyone's able to see it other than the panelists here. Vince, are they able to see the questions as well?
I believe so, Chris.
So I have two windows here. Like one is a chat that there's some things going on in the chat, and there's a question and answer. So I have two windows basically.
Christy's saying no, they can't see the question and answers.
Okay, so maybe we just want to I was just making sure that people knew what the question was.
Okay, so let me read it.
So yeah, sure.
If an existing building has no previous test records, would you insist that an engineer be involved prior to anyone? It means contractor, fire department official, fire alarm technician, testing the smoke control system. I think the first step is to involve an engineer. I mean, fire department, yes, they can go ahead and test the system or ask for your records and do whatever, and they ask for this basically, and then at that point you need an engineer to get involved to gives you the test, the maintenance procedure, or you know, the satisfactory operation. So if I switch back, so you still see my screen for this presentation, right?
Yep.
So if I go to the beginning of this, so this is all 7.3, right? So it's either 7.3.1.2, where the smoke control measures contained in commentary C are provided. They have to be done by the National Fire Code. That's one thing, but there's an overlap, as it says. 7.3.1.3 says, where a smoke control system is designed to meet the requirements of the building code, which could be part of a measure. The inspection and test of equipment shall be carried out in accordance with procedure established by the designer of the system. So assuming when talking about the existing building, we don't have this established procedure by designer. We don't have that. When they're not available, the smoke control system shall be assessed to ensure satisfactory operation using techniques. Okay. And then the next sentence says that when you did that assessment, you have to put together a procedure. And then the next sentence says that whole procedure needs to be stamped by an engineer. So technically, if you're going backwards, you need an engineer to do all this work for you. And then after that, you can move forward with the maintenance procedure, right? So to me, that's the first step, to involve an engineer to see what's going on.
So I suppose the tricky part is insisting on it, right? And so one of the key things is if you're looking at a measure or a system, and if you're following in the scope of 7.3.1.2, that's where it gets to be a bit of a gray area, right?
Well, I would say
under-
still 7313 is applicable, right? Even though you have 7312, because that's talking about measures, and measures include other things. Measures include like other, like doors in the vestibules, closures, and all things. But 7313 specifically is talking about the smoke control system, which again, something that is included in a measure. Part of a measure is a smoke control system. So, and this one, 7313, sentence 1, sentence 2, if you go there, it sends you back to SB4. So technically, SB4 is only for measures, right? So if you have it, sentence 1, 73131, is talking about a smoke control system, and this sentence sends you to SB4, the next sentence. So technically, they consider that a smoke control system being part of a measure too. So to me, that assessment is required, and you can't just go ahead like and do it based on the national fire code requirement without knowing what's in the building, what was done, and the whole procedure that we talked about. And that's my opinion, honestly. I don't know. What about OFC sentence 96216.2?
So I think we addressed that.
Yeah, the previous
earlier,
question.
right?
Yeah,
Yep.
it doesn't matter if it's
Yep.
a retrofit asking for it or. My question is, an existing building that is a measure M, unsprinkled with balconies, and they apply for a building permit for a new makeup air unit with or without heat. OBC 326251 applies as of January 1st. Yeah, I know that. This is in, oh, sorry, I'll have to read it. So if they apply for a permit for a makeup air unit, basically based on 3262 sentence 5.1, applies as of January 1, 2020. This is in contradiction with Measure M, Section 3, Sentence 5. What should we allow? So I have to read that, see what's the contradiction, to be honest with you. I don't know, I haven't dealt with that. But as part of the permit process, I think that needs to be considered. If you're doing a measure, we shouldn't be applying something that is not applicable to the, like, I mean, building code asks for new stuff. And I understand if there's an extensive renovation and you're applying part 3 requirements and all of a sudden this comes in. But if you know that there's a measure M in this building and this is basically in contradiction with that measure, definitely is not required to follow that, because you're affecting the entire performance of that system. And to me, that we shouldn't be doing that, because that was added considering new buildings. And mostly, there are sprinkled buildings we're talking about, they're measure A. So they asked for that to keep that sentence, to let everyone know, it's just keeping the corridors and residential occupancies pressurized. So we don't shut down on any fire unless there's a smoke in the duct, smoke in the in that fan. Other than that, we want those fans to be running all the time to pressurize those corridors. So if it's in contradiction with Measure M, I don't know what that is right now, because I have to review Measure M. But to me, that's not something that you should have in that building. Seeing page 51. I think that'll be time consuming to go through it and understand it, but I can definitely, I'll be glad, John, if you want to get in touch later to look into it, because this is an interesting thing. We can chat. You can email me. I mean, my contact information was here. Let me put it out again. Oh, great. I totally closed that thing. Okay, here. Yeah, I think we can take it off and talk about it. I can go through the Measure MC, what that, because this is interesting, right? This is something that building code applied to the new buildings, but if you want to apply it to an existing building, we're harming that basically. causing more harm to the building than any, good. So I think we shouldn't do that, but I can look into it further and we can chat. The other question is, I know of a building where ductwork collapsed due to exhaust fans being started before dampers were opened, or not enough dampers opened. Yeah, technically these fans should be designed that way. There's a sensor for them. If the damper is not open, the fan shouldn't start running. Right, that's one of the things that we look at it. So when we do the test, if the fan starts and damper is still closed, that's a no-no, right? So I believe there's an easy fix there. So they just add a sensor to just make sure if the damper is first open and they run the fan. It's been probably an old system. In new buildings, you don't see that because it automatically comes with that. So I believe that's an older building. So the next question is, one of the biggest concerns in that FPOs may not be familiar with all the components to the smoke control design for each building. How does an FPO, it's a fire prevention officer, right? FPO?
Yes.
Know
Yes.
if all the components were covered in the testing and confirmed as satisfactory. Makes it difficult to review. Are there particular test results we should focus on that can assist FPOs reviewing the test results and maintenance documentation? I think you can ask the engineer. Like, I don't know a best way of doing that other than some training for FPOs. I believe Chris is doing that to some extent. I don't know, maybe Chris, you can comment on that, but I think it's as long as you get a training that you understand like these measures and what you should be looking for and how what you want to see is how they justify that the system is working properly, right? If you see the steps that they took, you see they looked at the system, they did an assessment, they say, okay, the building code is asking for this, the system was installed based on this, we did a test, it's performing based on this. So these are the things that you need to see. If they just say, okay, we confirm in 2 sentences, or we confirm that the system is working, I wouldn't accept that. Like, they need to do an assessment, right? So I think you can tell when you're looking at the document that someone did an assessment or just did basically go into building, say the system is good.
And Ellie, sorry, first I should probably introduce myself. I never did that early on. Half the people here are probably wondering who the heck I am. So I work for Toronto Fire. I'm one of the training officers here. So we're looking at that for our staff. Yes, not in the context of doing the OMFPOA, but like you mentioned earlier, like for measure ends, right? We're looking generally for 12 pascals of positive air in the vestibule, right? But when you get into stairwells, I mean, in stairs, I think we've generally looked at 12 as being a bit of a benchmark as well. But it's like you said, it's not specifically mentioned in SB4.
Yeah.
And so, like you said, it can depend. What you're looking for can depend and vary from building to building. And that's where, as Ali was saying, like I think it's important to be asking those questions to the person providing the report of, how is this acceptable, and to justify that. Right, and justify the numbers and the readings that they're getting. Certainly, if you're getting, negative pressurization, that's a problem. But
Yeah.
once you're in the territory of getting positive pressurization, yeah, what is acceptable can vary from building to building.
Yeah, technically, yeah. To expand on that, Chris, is that when you're getting a positive pressure of, like, let's say 2-3 Pascal. So it's a positive pressure. Technically, the area is pressured, but you're doing this test in the summer. In the winter is not going to be, so probably in the winter you're going to get 0, or you may get negative. So that can affect. Usually, if you get a good result in the winter, in the summer should be good. So that's another thing to consider, right? So if you're getting a positive pressure in the winter in the shaft, so when it comes to summer, that should be good. But yeah, there's things that are very different, and each building is challenging. So yeah, but you need to look for that whole basically assessment in the report to just make sure that the engineer did that work, and not just based on just turning on and off the fan, they're saying the system is working, right? So that's not what the code is asking. So the next one says, are you able to provide examples of these periodic test inspection reports or templates of common smoke control test reports we may see in the field? Can these be found online anywhere? Honestly, there's nothing, there's no standard out there or anything that tells you how to do things. So I believe different companies doing it different ways. I've never seen from other companies like how they do it. I have our own, and unfortunately, we can't share that because it's a property of Jensen Hughes, and obviously, certain reasons we can't do that. But I believe maybe Chris seen multiple of those. I think as long as they're following the 3 steps, um, that should be fine. And they're giving you, I can actually share a one that I have for the, not the assessment part of it. I redacted some information here I was going to show you. Let me stop this thing somehow. And yeah, I can probably show you that. But that's just the maintenance. It's one of the appendix of the reports that we have. Right, so it's not the whole report.
While you're pulling that up, having seen a few of them, are you going to show one of the tables for a stairwell or something?
Yeah, these are just the test, like the forms that basically prepare for people to follow, and actually we use it for initial test. Right, so what kind of inspection you're doing is a 2-year annual or 3 months, and date and name and location, like the location of the fan. This is for below grade exit stair test procedure. So you got to follow, is it yes, no, or not applicable? Some notes here, a motor of supply, air fans are lubricated, blah, 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 pressurization fan activates upon fire alarm, motorized damper opens, automatic door opener. So this is like, this table can change with building to building because there are a lot of different things in different buildings. So you can't have one report, but generally this is what it looks like when it goes, when you see a report from us, an annual inspection. So basically you do the same thing with the power to be an emergency generator. That's the only requirement. So you do the same. And a 2-year inspection that I was talking about in the summer season, you got to do it in the winter season. So there was which one it was. So every 2 years you have to switch them. And you come to pressurized shaft, we talking about doors, airflow from shaft to floor area, yes or no, door to pressurized shaft is operable, and you have to provide the door force opening basically here. Any comments or notes? This is again just the form, not the whole assessment that we do. This is for natural ventilation above grade. Controls provided for above grade stairs, automatic door openers operate as intended from CACF room. Ensure the doors which discharge to outside of the stair open upon activation of the fire alarm. So this building had an automatic door opener, but it could be different when we're dealing with different building. Ensure that the doors which discharge to outside from the stairs are operable manually. So even though you can open it automatically, you have to be able to open them manually as well. And basically this is it, like control of makeup air unit procedure. So if they shut down and like you can control them from CACF room and all that. So this is what it looks like. This is the tables again, but you see as part of this report, you should see first an assessment, like a report is talking about the entire building, what measure they used, what are the size of the fans, the specification of the things in the building. And you see the results, like a result similar to this, unless they confirm that, we reviewed the air balancing and we skipped basically the initial test. Otherwise, you have to see something like this with the test results. And another attachment would be this like empty form for them that they can use it for periodic test and maintenance procedure. So this is pretty clear to follow, right? So they just need to take this form and just do it every 3 months and just keep it, right? That's all they need to do.
Are you okay showing them, I don't mean to put you on the spot, but are you okay showing them the table where you actually record the pressure readings on the
I don't
unpressurized and
have a
pressurized?
redacted of that one. I
Okay,
don't know
that's
if
fine.
you have one you can share it. I believe it sent you one, I don't know, some time ago.
Yeah, a while ago. I don't know if it's redacted either.
Yeah.
But Matt shared one with me. But essentially, like if you have a 20-story building and you're looking at, let's say, stairwell A, you're going to have readings on all stories, right? You're going to have a reading on the So for example, if we have a
Yeah.
pressurized stairwell, you're going to have a pressure reading using the manometer that Ali showed earlier. You're going to have a pressure reading on the corridor side and on the stair shaft side on each floor, showing the pressure differential. And then, certain companies like Jensen Hughes, for example, will also take the door opening force readings on each story as well. And then you'll have a table for stairwell A, a table for stairwell B, table for the pressurized elevator shaft, and so forth.
Yeah, exactly. So all that should be there. Yeah. And all the results, as I said, if we're dealing with an existing building and we're doing initial tests, right? Next question is, what are some common indications a building has a smoke control system besides switches and CACF room? Actually, starting with CACF room is a good thing, those switches. Other than that, if it's a high-rise building, right? So a high-rise is defined in the building code, as we said, the type of the occupancy, the height of the building, and you can say if they have a smoke control system. But usually in the CACF room, all the time, I mean, in the CACF room, there's a switch for a fan or something, so you would know what they have in the building. And based on the height of the building, if it's a smaller, like a mid-rise building, maybe it's not a high-rise building. It depends on the height again. It all comes down to 326 requirement. Or you have an interconnected floor space, right? You see some atriums, open atriums. First and second floor usually could be permitted, depends on the occupancy, but you see multiple floors that are interconnected. So definitely that's interconnection and smoke control system again
I
required.
know we've had some legal issues in the past of evidence that the smoke control systems were actually present. And certainly CACF switches is what I'd be looking for first as well. But
Yeah.
the fire safety plan is a resource. Physically
Yeah.
looking out in the field, like at the top of the stairwell, to see if there is a fan. Like Ali said, is it actually a 326 building that requires the measure? So those are all things that would
Yeah,
need to be taken into account.
Yeah, if you see a 326 building and there's nothing in it, sometimes I've seen it, people the designer applied to waive the stairs. Like there's a sentence, a very old OBC that tells you that in an apartment building, you can waive the pressurization above grade and both below grade. So designer at the time used those sentences. But the one thing that they could not escape was the elevator shaft pressurization. So if you're looking in the field, you don't see anything for the stairs, look for the elevator shaft. So if the elevator shaft is pressurized, usually that's a indication of the measure for that building. And yeah, fire safety plan, I mean, if they're done properly, in fire safety plan should be a section for a smoke control system describing the system in the building. But I believe you're talking about maybe an older one and something like that is not available. Yeah. But still, you can figure it out. There are ways, as Chris mentioned, that going through the building and just looking for the fans here and there, switches in the CACF room that you mentioned. The other question is, can you explain again OFC 7313 versus 7312? So basically 7312 is saying if you have measures in the building, you need to maintain them based on the 7.3 of National Fire Code. So any measure that you have in the building, you have to follow National Building Code, National Fire Code for maintenance procedure. But 7313 says that if you have a smoke control system to comply with OBC requirement, you have to follow an established, basically maintenance requirement provided by the designer. So the difference is that for a measure, you can go ahead and just follow National Fire Code. When it comes to smoke control system, meeting OBC requirement, you need the designer approach. If designer is not available, we get to a whole story of like another engineer come in and do this and that. But the discussion is that if you have a measure, are we okay with national? We go with 7312 only, or 7313 is still applicable, which because they're two separate sentences, both of them are applicable. So you have a measure, you follow national, but you have to follow 7313 as well, because as part of a measure, you have a smoke control system to meet the building code requirement, and then you have to do all this, right? This was the latest discussion that we had with Chris. I believe we got a confirmation. from OFM on that.
Yeah, we're still trying, Randy Delaney and the OFM and I are still going back and forth on it a little bit. Um, it's still a little gray in terms of how you would be applying 7313 to that. They've looked at these requirements in 7312 and 7313 as being really designed for measures that fall under 326. But as you mentioned earlier, that we also have systems outside of 326. One of the ones
Yeah.
you talked about was in 328 for interconnected floor spaces, right?
Yeah.
Like for those of you who are not familiar with all of them, if you open the building code online, for example, in ELAWS, you can control F search percent by volume, like the percent symbol, not the spelling. So if you search percent by volume, you can see the other, I think there's like 6 or 7 other references in the fire code or the building code, sorry, outside of 326.
Yeah.
And so we have requirements for, there's one for care occupancies. There's a couple in 328 for interconnected floor spaces. And this is where we get into the other smoke control systems that are outside of 326. And Randy and I are still trying to fully hash out what would apply where, right? I don't think this has really been pushed to the forefront on their end either.
Yeah, thanks, Chris. But yeah, technically this is how we apply this, and we look through both of them basically, and take into consideration both national fire code requirements, and also go to SB4 for techniques that are provided to do the assessment of the system. Next question says, sorry to clarify, for a building in existence on October 9th, 1992, would complying with any of the articles outlined in 96216 2A to E, I believe that's OFC, not mean that a smoke control measures aren't required? Comply with any of the articles outlined. If there is no retrofit application, if there is nothing in the building and there's no retrofit application for that, then you don't have the measures in the building. But I doubt in 1992 these measures were around, and they should have used it if you're talking about a high-rise building. So I'm not quite sure what the situation is exactly. But there are certain things that we need to look at, but 1992 is not that old. So yeah, I'm not sure if I added any value there, but yeah, I don't know. But 1992 is to me, it's been around, the measures. Just says fan must shut off during fire emergency. I don't know. John has a question. So just says fan must shut off during fire emergency. Oh, this is going back to that measure M question, I believe.
Yes, that's correct.
Yeah. Fans must shut off during fire emergency. Okay, that's a measure M. I can look into it and talk to John about it later if he contacts me. Because if this saying fan must shut off, there are different fans in different sections of the OBC. Even when the OBC is asking to shut off like the fan, it's telling you under if they're for kitchen or for washroom or whatever, you don't need to do that. Or certain fans you need to do it. So there are things that may affect this whole thing that need to be considered. So I have to review it. I have a building that during the smoke control testing, the firefighter designated elevator doors will not operate when the shaft fan is activated. That's not good. I have not seen this before. In this scenario, we were able to use the firefighter elevator when using the emergency operations for phase 1 and phase 2 of the elevator. Once we get to the selected floor, the doors will not open or close. This is a problem as we can have trapped firefighters. Have you experienced this scenario before? Do you have any general information on next steps? Definitely this seems to be overpressurized to me. So you got to look into the design of this. Like, I mean, the engineer needs to look into the design of this to see how they can resolve it. Sometimes, again, stack effect is a huge thing. And to be honest with you, I don't think the measures are in the SB4 are the best. They're very generic. right? So, and the designers just follow them because they're pretty simple. You follow it and you're done. But if you're following that and you're, first of all, it could be a fan of the bigger size that the building code asked, right? So they provided a bigger size fan for whatever reason, and they're over pressurizing that shaft. So that's one thing. The other thing could be, even if you're going with what building code is asking and you're dealing with something like this, then the designer has to change it, right? You want to have a pressurized space, but the doors to be operable. So you can go below that for a certain scenario. You can justify it, say, hey, building code is asking for 10,000 CFM fan here, but that 10,000 CFM fan is giving us hard time because the doors of the elevators cannot be opened. This could be because that elevator shaft is on the exterior envelope of the building. It's really, the wind is affecting a lot of things in that shaft, which is a huge thing. And it really depends if it's in the core of the building, what's around that. Is it a stairwell around it again that, exposed to exterior? So that's a designer needs to fix that. So that's not something that we want, obviously. Similar to the doors that are, when the stair shaft is over pressurized, you can't open them. This is the same, right? You get trapped in the elevator, you can't open the doors. And what's the use of that pressurization, really? I think that was the last question.
That's your last one. I do have one other one that I was emailed.
Well,
How are you?
okay.
Are you okay for time? It's a short. It should be a relatively short one, I think.
Yeah, I'm okay. I don't know
Okay.
if you guys, yeah.
This one was just about discussing the testing on emergency power, which I know you and I have run into before.
Mm-hmm.
Are you
So,
okay to chat about that for one moment?
yeah, sure.
Okay.
So, what's the question is like testing on
I think it's
emergency?
more about. I think the person who asked it's more aware of it. It's just more making other people aware of it. So
Oh,
just
emergency power, yeah.
can you
It's in the
test
National
for?
Fire Code.
Okay, sorry. Go ahead.
No, if I'm understanding the question correctly, maybe you want to add on it, Chris, before I go ahead.
I think it's more about just making people aware about the requirement to test these systems on emergency power as well.
Yeah, that's the annual inspection, right? The report that I showed you as part of the annual inspection. So you have your basically 3 month, and when it comes to annual inspection of the shaft, you got to do it on emergencies. Basically, you're following the same procedure every 3 months, but then complete the parking level exhaust fan test procedure above on emergency power. This is for parking fan, but for any fans, basically anything that you're doing every 3 months when it comes to annual inspection, you have to do it on emergency power, and that's coming from National Fire Code. So you got to make sure that it's on emergency generator, because this is important piece of it that we want. And what we do for initial test, we do it on emergency power as well, because that's your initial test. You got to consider the worst case. The worst case should be your initial test to just make sure that the system is going to be working, and the worst case scenario, like everything is on emergency. And what we do, we run the whole test on emergency. It usually takes about like 2 hours that it needs to be on emergency. So you make sure, sometimes surprisingly the emergency fails, and these are the things that you see, right? You're testing the smoke control system, but you all of a sudden realize that, oh, okay, so they have emergency power issue here, which again, you can catch it during these tests.
Fantastic. I had two quick comments to add on a couple of things in your presentation.
Sure.
One of your very first slides was the definition of smoke control systems in ULCS 524. And it's interesting because it's also in ULC 1001 for integrated systems. And it's interesting too, because they use, it's slightly different, eh? So in 524, they say a system of basically fans and dampers. And in 1001, they say fans and or dampers. And it seems to give you, I don't know practically if it would matter or not. But
It's better. I think it's the one
I
that
think
I
it's
was
better
talking
too.
the other day, that, the way that 524 is saying and, it means you have to have both of them. But, being involved in ULC writing, I don't think the wording of the ULC, you can compare it with OBC or fire code, the and or not, sometimes getting mixed up. People mean that and or, but they fixed it in S1001, it seems. But
Yeah, I think it's better in
yeah,
that too. Now,
yeah,
we do have the ability somewhat to pull that in as well, right? So in Division A of the Fire Code, in defined terms, in Article 1411, we have the ability, where we have undefined terms, and it talks about how we can use definitions for undefined terms within their general meaning. So
yeah.
it does give us a bit of an opening to pull those definitions in when we're referring to, for example, smoke control systems in 7.3, right, of the Fire Code.
Yeah, exactly. I agree that because you have a fire alarm system technically that controls the smoke control system, and 524 is a standard for the fire alarm system. It's not something totally irrelevant, right? So you're referring to a term that is in a ULC standard, which is applicable to the system that controls all these fans and stuff. Right? So it's better than going to a dictionary, like looking for, which you can technically when there's nothing available. But still there's something in the industry. I would rather to use that. And especially 524, which is again applicable to your fire alarm system, which is the heart of this, basically a smoke control system.
Yeah, absolutely. And the last thing I was going to add, you mentioned 90 newtons being the maximum door opening force in the Fire Code and Building Code.
Yeah.
And that SB4 discusses going up to 130 newtons for pressurized stair shafts, for example, or pressurized areas with openings.
Yeah.
So we do under 2721 in the Fire Code. It's 90 newtons is also referenced, but sentence 4 does give the chief fire official the ability to approve that 130 newtons, right? The way it's worded. So that's just for everyone's reference.
That's great. Yeah, that's great. Because SB4 again, I think I have that here for the door force. See, the writing is the maximum value of 130 Newton is suggested by research as the force that can be opened by the majority of people in most occupancies. However, this value is above the maximum value of 90 Newton generally specified in this code. The use of value below 130 Newton can create a practical problem in achieving effective smoke control, as it is difficult to design for the acceptable minimum and maximum pressure differential range. Right, so technically it says that we know that there's a 90 Newton, but we accept anything under 130 because if you want to go under that, it's challenging to design a pressurized area. Right, so it's something, some piece that needs to be read with the other requirements, and make a decision based on that by an engineer. I've been in buildings, honestly, it was it was a little bit over, but when I looked at the type of the occupancy, it's a retirement home and it's a senior living center and stuff like that. So we have people with certain age, certain disabilities and whatnot. So on that, I'd rather to see the 90 Newton, and especially it was achievable. You could say that it was achievable to do that. It wasn't a new building. The designer was involved, so you can actually talk to them and bring it down. Most of the times it works, but sometimes, like you're dealing with a 30-story building, like an existing one, an above grade, fan, and it's not doable. You can't do anything about it.
Excellent. And there's one more question popped in about which definition for smoke control system should we be using going forward to be consistent. We're not that bound by it because it's not in the fire code. However, I think Ali and I agree that the definition in ULC S1001 is better because it says and or.
Yeah.
And that can be found
I believe that will be fixed in the next edition of 524. Because somebody caught it, because S1001, I know it's been revised after that 524. So it got caught, but it was too late to go back to 2019 524 to add that. So I would, because the definitions are, again, I'm sitting in those committees and I see how it works, and we try to make all these definitions like in line with each other. Like when you start working at 524, a bunch of other standards, you're looking at the definition. So you don't want to have different definitions and different ULC standards, right?
I don't think practically it's going to be a big issue
No.
for an inspector.
No, it's still
but
524. You can read it that way, that
Yeah.
either a fan or
Yeah.
a damper could be considered that. Yeah, I agree.
So that's, anyways, sorry, that was the end of my comments as well. That's seems to be the last question that we have.
All right. So I think that's it. If there are no other questions, thank you very much, everyone.
Thank you very
for
much, Ali.
joining. Yeah, no worries.
That was fantastic, Ali. Thanks a lot.
Yeah,
That was much appreciated. I think we all got a lot out of it.
that's great to hear that.
I don't think we
Thank
ever
you.
get this many questions and answers on a subject. So it just shows that everyone's engaged and obviously interested in hearing what you had to say. So yeah, that was great. Thank you.
Thank you. Thank you, everyone.
Thanks, Ali. I do have a little bit of OMFPOA stuff just to share with everybody, some updates and just what's going on. So the symposium's coming up soon in London, the 5th and 9th of June. All the details are on the website. Get your registrations in soon if you're planning on coming. At the symposium, we'll be holding our annual general meeting. So we'll be having elections there. This year, there'll be open up positions for the vice president, secretary, and 3 director positions. So if you're wanting to run or you're wanting to nominate someone, get those nominations in. There's a form up on the website to have filled out with your chief's support. Also, at the symposium, we give out our annual award. So we're looking for nominations for that. So there's the Jim Copeland Award, which is awarded to any citizen or group that you think has done well in fire prevention and that. So looking for nominations for that. The Dave Sylvester Memorial Bursary for students. So if any of you know any students that are taking fire protection, have them apply for that. And then a couple of big ones, the Al Suleiman Award. So that was renamed. That's our old fire prevention employee of the year. So if you know anybody that's worthy of that, nominate them. Great to see them get recognized like that. And the other one, Fire Chief of the Year. I know there's some fire chiefs out there that do great work and support their prevention. Let's recognize those chiefs that are stepping up and doing everything for the prevention team. And not yet on the website, but I will be putting it up. This will be issued out as well as the fire prevention and public education grant that's issued to fire departments. There'll be 3 grants of $1,000. The application form should be up later today or tomorrow up on the website for that. So thanks a lot, everybody, for attending. Thank you very much, Chris from Toronto, for setting us up with Ali. It was much appreciated. And thanks, Ali, for the presentation. It was great.